The number one hidden danger of vitamin D you must know. Expanding on the importance of vitamin D. Hello, health champions. Today, we're going to embark on a deep dive into a topic that is perhaps underappreciated, yet incredibly vital for your overall health, vitamin D. It's not just a vitamin. It's actually a potent steroid hormone that plays a foundational role in countless biological functions within your body. You can make a very strong argument that vitamin D is the number one nutrient deficiency in the world, and not only that, but it is critically important, and we've only just begun to realize its true significance in recent years. Imagine this. If you could only pick a single marker from a blood test to assess a person's overall health status, vitamin D might very well be the top choice. Why? Because your vitamin D status correlates so closely with your overall level of function, from your energy and mood to your ability to ward off illness. Scientists have even started calling vitamin D a biomarker of chronic disease and debility. This means that low vitamin D levels aren't just a minor issue. They often accompany or even precede a vast array of serious and prolonged health problems. Vitamin D deficiency has become a silent, global pandemic. Despite living in a sun-drenched world, modern lifestyles, dietary habits, and environmental factors have led to a majority of the population being deficient. This isn't a problem confined to countries with long winters or less sun. It's a worldwide issue, affecting every race, age, and gender. The alarming truth is that many of us aren't even aware we're deficient, and even health-conscious individuals may not grasp its severity and widespread nature. Historically, when people thought of vitamin D, they immediately thought of strong bones and teeth, preventing rickets in children and osteoporosis in adults. Yes, that's its classic, an extremely important role, but as I will explain in more detail, that's just the tip of the iceberg. Science has made huge strides in uncovering a myriad of non-classical roles for vitamin D, roles that we've only truly come to understand in the last decade. These discoveries have ushered in a new era of viewing vitamin D not just as a simple nutrient, but as a key regulatory factor for overall health and disease prevention. We'll delve deeper into the potential dangers of suboptimal vitamin D levels in the body, and from there, we'll provide a specific number of crucial steps we must all take to properly utilize vitamin D. If you'd like to follow along and grab a copy of these slides, there's a link below where you can download them right now. Let's embark together on this journey to unlock the true power of vitamin D and equip ourselves with the knowledge to safeguard our own health and that of our families. Beyond bones, the non-classical roles of vitamin D. When we talk about vitamin D, its classic role is the first thing that comes to mind for most people. That's how vitamin D helps the body absorb and utilize calcium and phosphorus, two essential minerals for building and maintaining strong bones. This discovery dates back to the 1920s, when scientists realized that severe vitamin D deficiency was the cause of rickets in children, where growing bones couldn't harden, and osteomalacia in adults, soft, weak bones. Vitamin D supplementation immediately solved the problem of rickets. This was a revolutionary finding and saved countless children's lives. However, as I mentioned, that was just the starting point. In the last decade, we've learned so much more about the non-classical roles of vitamin D, roles that relate to virtually every system in the body. This has truly been a revolution in medicine and nutrition. Let's explore some of these crucial roles. 1. Immune function. This is one of the most well-researched and significant non-classical roles, especially in the context of pandemics and infectious diseases. Vitamin D plays an incredibly vital role in activating and modulating immune cells. It doesn't just help the immune system respond more robustly to pathogens like bacteria and viruses. It also helps regulate the immune response to prevent overreactions that harm the body, as in autoimmune diseases. When vitamin D levels are low, the body's defenses are weakened, making you more susceptible to infections and illnesses. It acts like a switch that helps T cells and B cells function effectively, as well as supporting macrophages and natural killer cells. This regulatory role is particularly important in maintaining immune balance, preventing unnecessary chronic inflammatory responses. 2. Inflammation regulation. Inflammation is the body's natural response to heal and protect. However, chronic, prolonged inflammation is the root cause of so many chronic diseases. Vitamin D is extremely important in regulating inflammation. If vitamin D levels are low, inflammation goes up. This means your body is constantly on red alert, causing cellular and tissue damage over time. By reducing inflammation, vitamin D can help prevent and manage conditions like cardiovascular disease, type 2 diabetes, and many other autoimmune diseases. It impacts pro-inflammatory cytokines and signaling pathways involved in inflammation, helping the body better control its inflammatory response. 3. Neurogenesis and brain health. This is perhaps one of the most exciting discoveries. Vitamin D is involved in neurogenesis, which means building new brain tissue, creating new brain cells, and new brain connections. Think of it as a brain nutrient. This is particularly important for repairing brain tissue after concussions or traumatic brain injuries. But not only that, vitamin D is also necessary for learning new things. Every time you learn, your brain makes new connections, and vitamin D plays an essential role in this process. It influences the production of neurotrophic factors like BDNF, brain-derived neurotrophic factor, a protein crucial for the growth, function, and survival of neurons. Thus, optimal vitamin D levels can support cognitive function, improve memory and mood, and reduce the risk of neurodegenerative diseases. 4. Apoptosis, longevity, and programmed cell death. This sounds complex, but it's a natural and necessary process the body uses to eliminate damaged or unnecessary cells. This process helps maintain balance and prevents the growth of abnormal cells, like cancer cells. Vitamin D is extremely important for regulating this process of apoptosis. When this process doesn't work efficiently, damaged cells can persist and multiply uncontrollably, leading to disease. Vitamin D helps ensure cells undergo their proper self-destruct program, when needed, contributing to genomic stability and overall tissue health. 5. Cell proliferation, differentiation, and genomic stability. These are core concepts of cell biology, and vitamin D plays a crucial regulatory role. Cell proliferation is the process where cells multiply. Cell differentiation is the ability of a stem cell to become a specialized type of cell, e.g., a bone cell, heart cell, liver cell, or brain cell. Genomic stability is the ability to maintain the stability of your DNA genetic structure. When vitamin D is functioning optimally, we have healthy tissue. However, there's something called cancer. Cancer is characterized by uncontrolled cell proliferation, poor cell differentiation, and genomic instability. These three things, along with low vitamin D levels, are intimately linked to cancer, especially malignant, uncontrolled cancer. Vitamin D has the ability to regulate the cell cycle, prevent the excessive growth of abnormal cells, and promote their apoptosis. This suggests that vitamin D can play a strong protective role against the development and progression of many types of cancer. Another disease that's becoming rampant is autoimmune disease. These are conditions where the body's immune system mistakenly attacks its own tissues. Vitamin D is a powerful immune modulator and can impact many common autoimmune conditions such as rheumatoid arthritis, systemic lupus erythematosus, ankylosing spondylitis, psoriasis or psoriatic arthritis, and even type 1 diabetes, an autoimmune disease that destroys insulin-producing cells in the pancreas. The list goes on and on. Vitamin D helps balance the immune response, preventing overzealous immune cells from attacking healthy body tissues while bolstering defenses against actual pathogens. And then we have all the neurodegenerative diseases, which are a decline or deficiency of nervous system tissue, such as Parkinson's disease or Alzheimer's, as well as neuropsychiatric disorders like schizophrenia and depression. Low vitamin D levels have been linked to a higher risk of developing these conditions and can influence their severity. VitaminD protects neurones, reduce neuroinflammation, and supports crucial neurotransmitter pathways. So, I think you can begin to see the importance of vitamin D. There's almost no bodily function in which vitamin D is not involved. To call important is an understatement. As we said before, you could look at vitamin D as a single biomarker and get a pretty good handle on this person's overall health. A good question is whether vitamin D is a cause or an effect of illness. In other words, do people get sick because they don't get enough vitamin D? Or is low vitamin D a result of them being sick and unable to properly process or utilize it? The answer is definitively both. If you're deficient in vitamin D, that can cause all sorts of health problems. And if you're sick, you're going to have a harder time processing vitamin D, creating a vicious cycle. This highlights the importance of maintaining optimal vitamin D levels for both disease prevention and to support recovery when illness is already present. The global deficiency crisis. Are you getting enough? How serious is the problem of vitamin D deficiency worldwide? Officially, you're considered deficient if you have levels below 20 nanograms per deciliter, Ing/dl, on a blood test. This number indicates that approximately 42% to 97% of the world's population is deficient, depending on different regions and countries. In some countries where foods are more fortified with vitamin D, the rate might be lower, around 40%. But imagine, that's still 40% of the population in those places with levels below 20 nanograms, a shockingly low number. And in some other areas, particularly in the Middle East or regions with cultural practices of covering the body, you can see up to 97% of people being deficient. When these numbers came out, there was some pushback saying, it can't be true that this many people are deficient. So, some organizations tried to change the guidelines a bit. They said, we found that even at 12.5 nanograms, most people are still mineralizing their bones pretty well. But look, they reverted to the classic role of vitamin D. They were primarily concerned with whether you can get calcium into your bones. They weren't really addressing the much bigger picture of the hundreds of other crucial non-classical functions of vitamin D. Even 20 nanograms is simply too low if we consider its full range of roles. Moving to the next level, they won't call you deficient, but merely insufficient, which is when you're below 30 nanograms per deciliter. But as I've suggested, many of these numbers are primarily related to the classic role of whether we can mineralize bone. So the question becomes, what's truly optimal if we want to take full advantage of the benefits for these hundreds of important functions? What level do we truly need to be at? To understand this better, we'll look at a couple of crucial steps we need to take to optimize our vitamin D levels. The challenge of sun-derived vitamin D production. Classically, the idea is that we go out in the sun and we get sunlight. When our skin is exposed to ultraviolet B, UVB radiation, we make vitamin D in our skin and everything should be fine. However, today, most people would agree that what we can produce through the skin is simply not enough. There are so many different factors that can hinder this process. Air pollution. Too much air pollution can block those UVB rays from reaching our skin, reducing our ability to produce vitamin D. Indoor lifestyles and clothing. If you were stark naked in the sun all day, you'd probably be fine. But I find most people tend to wear clothes and spend a fair amount of time indoors under artificial lights. This significantly limits the amount of skin exposed to the sun and the duration of exposure. Skin pigmentation. The darker your skin, the more you repel that ultraviolet radiation. Therefore, the darker your skin, the less able you are to convert and make vitamin D. Individuals with darker skin tones need significantly longer sun exposure to produce the same amount of vitamin D as those with lighter skin. Geographic location. If you live very far or quite a ways from the equator, you're also not getting as much sun or not getting the same intensity of sun. The intensity will vary by season and time of day. For example, in winter at high latitudes, the sun's angle is too low for UVB rays to effectively penetrate the atmosphere and reach the skin. Time of day. Even if you're in a sunny region, If you're out in the sun mostly late in the day, late afternoon, the sun is not strong enough to truly convert much vitamin D. The best time for vitamin D synthesis is generally around midday, when the UV index is highest. Age. As we age, our skin's ability to convert vitamin D also significantly declines. This explains why older adults are particularly susceptible to deficiency. Health conditions. Various conditions like insulin resistance, which 80% of the population has to some degree when they eat too many carbohydrates and too much sugar, also impedes vitamin D production. When insulin stops working properly, the body has to make more and more insulin and becomes insulin resistant, which also impededly affects vitamin D synthesis. Liver or kidney diseases can also impair the body's ability to convert vitamin D into its active form. So for most people, the only realistic alternative is to supplement vitamin D through diet and/or supplements. While a few foods contain vitamin D, we'll see that it's very difficult to achieve optimal levels through diet alone. The journey of vitamin D in the body: absorption, transport, and activation. Now, when we take vitamin D, whether through diet or supplementation, its journey in the body truly begins. It's a complex process involving multiple steps, and each step needs to be optimized for vitamin D to exert its full effects. 1. Absorbing vitamin D from food or supplements. When we eat vitamin D, whether in food or as a supplement, it goes into the stomach and small intestine. To break it down and absorb it, we need digestive enzymes. Because vitamin D is a fat-soluble vitamin, it's absolutely crucial that you take it with fat. If you eat a very low-fat diet or don't secrete enough bile, for example, if you've had your gallbladder removed or have liver issues, you won't be able to effectively break down and utilize that vitamin D. In fact, studies have found that by taking vitamin D supplements with your largest meal of the day, which typically contains fat, you can increase your absorption by up to 50%. This is because vitamin D is absorbed as part of the dietary fats. A larger meal also stimulates the production of more digestive enzymes, aiding the absorption process. Dietarily speaking, there are very few truly rich food sources of vitamin D. Animal products have small amounts, but the only truly rich sources are cod liver oil and cod liver, if you eat those things regularly. The only significant plant source is UV-irradiated mushrooms, meaning mushrooms that have been exposed to ultraviolet light to boost their vitamin D content. Small amounts are also found in animal products and animal fats like butter, cream, animal fat, and eggs, but usually not enough to reach optimal levels. Therefore, supplementation is really the only practical and sensible way for most people to get their daily required vitamin D. 2. Transporting vitamin D in the blood. The role of vitamin D binding protein, VDP. Just because vitamin D has gone into your stomach and you've managed to absorb it and even get it into your bloodstream, it's not yet doing you any good. It needs to be transported to the cells and tissues where it will act. There's a special protein called vitamin D binding protein, VDP for short. VDP is the primary transporter for vitamin D in the blood. Virtually no vitamin D floats around freely. It's all carried to where it needs to go by this VDP. If this protein is low, that means there's less active vitamin D available, even if your total vitamin D levels in the blood appear sufficient. This means you not only need to have enough vitamin D, but you also need to have enough of this transport protein. They've found that if you don't have enough VDP, for example, there could be an increased risk for malignancies, particularly breast cancer, prostate cancer, and colorectal cancer. There's a strong correlation between these cancers and low VDP. Of course, if you don't have enough of this protein, taking more vitamin D will still be helpful so you can better saturate the existing VDP, so there's more free and available vitamin D. In fact, I've seen that in a group of people taking only 1,000 international units, IU, per day, which is not very much, still reduces the risk of these cancers by 60% to 77%. This shows the importance of having vitamin D available for VDP to transport. 3. Getting vitamin D into the cells. The role of the vitamin D receptor, VDR. VBP can only transport vitamin D, but now we need to get it into the cell for it to exert its biological function. This is the next step, and it involves something called the vitamin D receptor, VDR. The binding protein will take this vitamin D from the blood or from the skin to its target organ. And now we have these little receptors on the surface of the cells. Only when those VDRs are functional can we get vitamin D into the cell and express that biological function. What's incredible is that these vitamin D receptors are essentially present on every cell in the body, but they are more highly expressed in places where vitamin D is most important. These would be places like your kidney cells, your immune cells, your bone cells, but also in specific places in your nervous system and many other different places. In the nervous system, VDRs are especially important in the substantia nigra, which is involved in making dopamine and diseases like Parkinson's. If you have low vitamin D, you literally cannot get full activity out of the substantia nigra. The dopamine levels will drop, and you're at a higher risk for Parkinson's disease. Hypothalamus, which is the area that regulates hormones, hunger, thirst, and body temperature, and so forth. When these areas are not functioning efficiently, we have neuropsychiatric effects like depression, schizophrenia, cognitive neurological diseases like Parkinson's and various motor disorders, and memory loss. We even have many different endocrine disorders and hormone imbalances. Even diabetes has a very strong correlation with vitamin D, and they link it specifically to this vitamin D receptor, both type 1 and type 2 diabetes. When vitamin D is low, there's less insulin released, we produce less, so we can't control blood sugar. But the main reason, of course, for type 2 diabetes is insulin resistance. When we have plenty of vitamin D, insulin resistance goes down. When vitamin D is low, insulin resistance goes up. And when our immune system is compromised, if immune-regulating vitamin D is low, we have less defense against type 1 diabetes, which is an autoimmune disease. Vitamin D's support team, essential cofactors, to be able to get through all these different steps, from absorption to transport to getting vitamin D into the cell, and truly get the full activity of vitamin D, we need a support team of cofactors. Most nutrients, most enzymes, and coagents work with other things. Vitamin D is not a solo player, but a team player. If any team member is missing, the overall performance will be affected. Here are the most crucial cofactors for vitamin D to do its job optimally. 1. Healthy, nutrient-dense food. This is the #1 foundation. Nothing replaces a healthy diet rich in whole, properly grown and prepared foods. Whole, natural foods provide a vast array of essential nutrients, vitamins, minerals, and phytochemicals that act as coagents for countless biochemical processes in the body, including vitamin D utilization. If you're eating processed foods and a lot of sugar, you're going to be deficient in almost everything. Processed foods not only lack cofactors, but also create an inflammatory burden and metabolic dysfunction that impairs the body's ability to use vitamin D. Focus on dark leafy greens, fruits, nuts, seeds, whole grains, high-quality proteins, and healthy fats. 2. Regular exercise. Believe it or not, exercise is a crucial cofactor for vitamin D. Exercise optimizes the function of every cell in your body. It activates biochemical pathways, improves blood circulation, reduces inflammation, and enhances insulin sensitivity, all of which indirectly support vitamin D metabolism and utilization. Exercise allows your body to function at its best potential, creating a favorable environment for vitamin D to perform its roles. Even daily brisk walking can make a significant difference. 3. Adequate vitamin D levels. Whether you're getting it from the sun or need to supplement, it's obvious that you have to have enough vitamin D one way or another. Not having enough vitamin D is the core problem, and cofactors can only help maximize the vitamin D that's available. If vitamin D levels are too low, even with sufficient cofactors, it won't compensate. 4. Magnesium. Magnesium is involved in hundreds of different chemical reactions and pathways in the body. And here's the kicker. Magnesium is the single most important concurrent factor for vitamin D to do its work. Magnesium is required by enzymes in your liver and kidneys to convert vitamin D into its active form. If you're deficient in magnesium, even if you take high doses of vitamin D supplements, your body simply can't effectively utilize it. This is a common problem, as many people are also deficient in magnesium due to poor diet and depleted mineral content in soil. 5. Omega-3 fatty acids, EPA and DHA. Omega-3 fatty acids, particularly EPA, eicosapentaenoic acid, and DHA, docosahexaenoic acid, are also crucial for vitamin D activation and transport. They are structural components of cell membranes, which helps improve the function of the vitamin D receptor, VDR, allowing vitamin D to enter cells more effectively. Omega-3s also have powerful anti-inflammatory properties, supporting vitamin D's role in immune modulation and inflammation reduction. 6. Zinc. If you haven't noticed, zinc tends to show up everywhere, and this is true for vitamin D as well. Zinc is an essential trace mineral that plays a role in over 300 enzymes and is involved in immune function, DNA synthesis, and cell division. It's also believed to influence the function of the vitamin D receptor, helping to enhance the cell's responsiveness to vitamin D. 7. Boron. Boron is another less known but critically important trace mineral. It plays a role in hormone regulation, including vitamin D and magnesium, and can help extend the half-life of vitamin D in the body, meaning it makes it last longer and be more effective. 8. Vitamin K2. Vitamin K2 is an important nutrient often discussed alongside vitamin D, especially when it comes to bone health. Vitamin D helps absorb calcium, but vitamin K2 ensures that this calcium goes to the right places, into your bones and teeth, rather than accumulating in soft tissues like arteries or kidneys. Some people need to take K2 as a supplement. Some people can make it via their gut. And we also get a little bit through food, e.g. natto, hard cheeses, egg yolks. Many times, you'll see vitamin D3 supplements combined with vitamin K2. I don't find that to be optimal in most cases. I find that many people need to start with vitamin D3 by itself and do that for about a 3 to 6 month period to significantly raise vitamin D levels. Then, some of them will start supplementing with vitamin K2, especially if they have concerns about bone health or cardiovascular disease. The goal is to have enough of both. The importance of blood testing. We've pretty much concluded that most people should be supplementing with vitamin D. But what's the basic recommendation? The standard guidelines usually say that you should get at least 600 IU, international units, per day, and if you're 60 years or older, you should get 800 IU. If you're in another part of the world, sometimes they measure this in micrograms, and then you divide the international units by 40 to get micrograms, e.g., 600 IU equals 15 micrograms. Some nutrition labels will have both units. The standard guidelines also say that 2,000 IU is the maximum you can get without supervision. This is a huge problem. For many people, 2,000 IU is not going to be enough. While there are many genetic factors, sun exposure, etc., that influence individual needs, clinical experience shows that 2,000 IU will not be sufficient for most people to reach optimal levels for the non-classical roles. 5,000 IU will work for many people and is often the starting dose many functional practitioners recommend. However, we also have plenty of people in the clinic taking 5,000 IU, and they're still deficient even after months of being on that. We test vitamin D on everyone in the clinic and find that some people are taking 10,000 IU, and this is probably too much for most people to take long-term. In our clinic, we find that the vast majority of people can maintain at about 5,000 IU. If they're truly severely deficient, we might bump them up to 10,000 IU for a month or two to rapidly bring levels up, but long-term, 10,000 IU can put you at risk for vitamin D toxicity, which is also something you really don't want. Here's the bottom line. Because there are so many variables, so much individual variation, and so many factors affecting vitamin D absorption, transport, and utilization, You literally don't know where you're at unless you measure it. You have to get a blood test. Next time you get a blood test, ask your doctor or ask them to include vitamin D on the list of tests. Once you get the result from your blood levels, what are we talking about as good levels? Less than 20 nanograms/dl or less than 50 nanomoles/L, as we said. This is severely deficient, essentially too low, in the red zone. Below 30 nanograms/dl or less than 75 nanomoles/L. This is the orange zone, meaning you're insufficient, still too low for the crucial non-classical functions. Optimal range, between 50 and 80 nanograms/dl or 125 to 200 nanomoles/L. This is the number that most people involved in functional medicine, nutrition, and holistic practices who do a lot of blood testing and specialize in this area will target. The lower end of optimal is around 50 ng/dl, and the higher end of optimal can be around 80 ng/dl. The reason why we want you in this range, and for many people, you might want to aim for the higher end, e.g. 60 to 80 ng/dl, is that while some people might do fine at 30 ng/dl, there's a lot of individual variation in terms of absorption. In terms of your vitamin D binding protein, VBP, and vitamin D receptor, VDR, transport, and the availability of your coagents. If you have one or more limitations in these processes, you have to compensate by having more vitamin D. So, if you're hovering at the higher end of the optimal range, you're in a better position to contend with these individual variations. We also ask people to engage in continuous blood testing and monitoring. This is particularly important because there is such a thing as vitamin D toxicity. If your blood levels of vitamin D get too high, it can cause your blood calcium levels to become too high, called hypercalcemia, which can cause all sorts of problems in your body like nausea, vomiting, constipation, muscle weakness, fatigue, and even kidney damage or kidney stone formation. So, you really don't want to go too high. 100 nanograms/dl or 250 nanomoles/L. This level is a cautious upper limit. Above 150 nanograms/dl or greater than 375 nanomoles/L, this is where it becomes a real problem, known as vitamin D toxicity. It's not easy to reach this toxic level. You might have to take tens of thousands of IU per day for quite a long time. However, as we said, there's also some individual variation. We've had people get up to 100 ng/dl without really high doses. For some people, 2,000, 3,000, 4,000, or 5,000 IU is sufficient. But other people have to take 10,000 IU, and they still don't get to optimal levels. This further reinforces why you need to measure. You need to know where you're at, and you cannot just take 2,000 or 5,000 IU and assume you're covered. Your action plan for optimal vitamin D: test, supplement, and monitor. I hope you've seen that vitamin D is simply too important to ignore. Too important not to know where you stand. It governs so many crucial bodily functions, from your immune system and bone health to brain health and the prevention of cancer and autoimmune diseases. So, what's your action plan for optimizing vitamin D? 1. Test. The first and most important step is that you need to measure your vitamin D blood levels. This is the only way for you to know exactly where you currently stand. You cannot guess or rely on general recommendations. Talk to your doctor during your next physical and request a vitamin D test. You need to know where you are before you can make any supplementation decisions. 2. Supplement based on measurement. Once you receive your results, work with your doctor or a nutritionist experienced with vitamin D to determine the appropriate supplementation dosage. If you're severely deficient, below 20 ng/dl, you might need a higher dose for a short period to rapidly bring your levels up. If you're in the insufficient range, below 30 ng/dl, a moderate daily dose can then be considered. If you find this video helpful and truly want to take control of your health by understanding how your body works, be sure to subscribe to the channel, click the bell icon, and turn on all notifications so you don't miss any videos that could save your life. We are here to empower you with the knowledge and tools you need to become the champion of your own health. Are you ready to get your vitamin D levels tested? Share your thoughts in the comments below.